Hello everyone, today we'll be talking about how do we work with tuple within Python environment. A lot of people will be wondering what's a tuple and why do we need it? Yeah, I think it's best done in terms of explanation when you go into the code environment and then showcase what exactly we have in mind. Now, let's cast our mind back to what we worked on in the previous video on list. We saw a list as a container that can contain objects that are similar, and it can also contain objects that are not similar. So your list doesn't necessarily have to contain texts alone or numbers alone. You can have a list of numbers, you can have a list of text. You can actually mix these two together with some other variable, types or data types. List can accommodate all of that. And we saw that list is flexible. However, when we're working with tuple, we don't have that degree of freedom, that we don't have that level of flexibility when we are dealing with tuple, and there is a reason for it. And there are many contexts in which you will need to use a tuple. So let me demonstrate this to us and show us when you will likely need to use tuple when you're programming in Python. So I'm creating a new Jupyter notebook here, and then I'll take our mind back to what we did before. We had our fruit as a list. And then we added things like apple, orange. We added cherry. Maybe we just called it mango or banana. Yeah, we had this as fruit, and it worked perfectly when we executed this. So let's try it again. I use this as my kernel. Yeah, so this is our list. And we saw how you can add more elements to it and then remove element from it. Those two options are not available when we're dealing with tuple or tuple, as the case may be. And I'll show you why. For instance, if I want to produce a tuple, I can say weekdays, and I go in, I'll use the parenthesis symbol, not the square bracket. These square brackets are used for lists. I am not producing a list, rather I'm producing a tuple, and I can come around and say Sunday is the first element, Monday is the next element, Tuesday is next, Wednesday is next, followed by Thursday, Friday, and then Saturday. Now, this is my tuple. It executes successfully. I haven't created this. I cannot come into another line and say weekdays dot append. You can see there is no such method. I cannot say dot insert. There is no such method. When you create tuple, it is finite and final in its nature. You cannot add to it. You cannot remove from it. There are ways around this, but in its most basic format, you can add to these elements that I have here, and you can remove from them. You cannot even change the sequence. It's pretty much static. It's like you create something and it is sealed and finalized. You can't make adjustment to it. And you start wondering, why would I need such a data structure as a programmer? That doesn't give you flexibility. Yes, it's pretty obvious from the example that I have on the screen. When you're dealing with fruit, you want flexibility. You want to be able to add elements to such a list of items. when you're dealing with something that has a finite list of elements, you cannot use list because list will allow people to adjust the content. Rather, you need to come and use a tuple. So these are the 7 days of the week. There can be the eighth one. The only thing that can happen is if I go into the definition and I add, say, another Saturday. If there is any business case for me to do that, I can add another Saturday. Of course, Tuple will allow me do that. That has to be said clearly. But this is being done manually upon creation, not like I'll go and do a dot insert or a dot append at any point. Duplication of value is allowed in tuple just like it is allowed in list. But this really doesn't make any business sense to me, so I'll probably just remove it and keep it the way it is. So these are my weekdays. If I run it, I'll see those days and you see they're in parentheses. If I'm interested in knowing how many elements I have in my tuple, I can simply say the length of weekdays. If I execute this, it tells me there are 7 elements in there. Can I delete the entire tuple just like we cleared all the elements in fruit? Yes, but I don't want to go that route yet until the very last element when I will execute the delete, and that removes the variable itself as well as the content. But let's play around with more options when we're dealing with tuple. It's not as useless, quote and unquote, as it appears to be. So let's say we have tuple 1 and we put 1, 2, 3 in there. I can even go as far as say 4. And then we have tuple 2, and then we put 5, 6, 7, 8. Okay, 4 elements. This looks fair enough. It is possible for me to do tuple 3 is equal to tuple 1 plus tuple 2, and then I can ask Python to display the result for me. So let's just format this cleanly, and then we see what our result is going to be. So it combines tuple 1 with tuple 2. The elements of both are combined into tuple 3, and that is what is displayed for me. But you'll see that in an attempt to change the elements in tuple 1 and 2, we are creating a third variable. So it's not like we're adjusting tuple 1 or adjusting tuple 2. Rather, we are combining the content of both in order to create a third variable, which is also a tuple. Now, what if I want to go around the corner to update the content of either tuple 1 or tuple 2 without necessarily doing it as a tuple? How do I go about doing it? There is a workaround. Let's say you figured out eventually that tuple 1 is supposed to contain 5 and tuple 2 is supposed to contain 9 in addition to the existing element, and you've already defined them as they are. How do you go about modifying that? Pretty simple. We can say let me create a list, say temp1, and this is going to be a list based on tuple 1. Okay, then I'll say create temp2 by converting tuple 2 to a list. So if you go check temp1, you will see that it has a list now, not a tuple. And if you check temp2, you will see that it also has a list 5, 6, 7, 8 and not tuple as it had prior to now. So it's possible for me to now say temp1.append. We're going to append 5 to it, Then we're going to do temp2 dot append. We wanted to append 9 to it. This works perfectly for us. We don't have a problem. So if you check temp1, you will find those extra, no, the extra element is there. If you check temp2, you will find the extra element of 9, which is in here. So what we can then do is to say, having seen this, we will now do like convert temp1 to a tuple. Maybe I'll just call it T1. And then T2 will be convert temp2 also to a tuple. And that should work. Everything works fine. And then we can say show us T1. We can see now that it has converted it back to tuple from the initial list 1, 2 to 5 that we have here. And if you check T2, it should also convert the figures back to a tuple state. Now it has 9, unlike before that we were seeing it as a list. Here we have it as a tuple. So that's a way in which you can play around modifying the content of your tuple. Now, a lot of people may be wondering, apart from you using it in the case of dates, like these days of the week or department within your company or months of the year or names of football teams within a league, which has to be static, it can change for a given season. What are the other use cases that will make you want to think about using tuple? If you do a bit of games programming in Python and you need to declare the position of your object on the screen, you need to be familiar with the concept of x, y coordinate on the screen. And usually we use tuple to indicate that. So when I indicate a variable scenario like this, in games concepts, I'm saying my x is at 0, y is at 0, and that's referring to the top left corner of the screen. Something contrary to your typical geometry in maths, where x and y axis meet themselves on the lower side. In games, you start from the top left corner of the screen. That's 0.00. So if my screen is say 1200 pixel wide, this point 1200 is saying the top right corner of the screen and not the reverse situation in basic college geometry. So people can use this sort of notation when they're programming games, and they can detect the position of objects on the screen based on the values of x and y, and it comes in handy in similar task when you are writing Python code. So I hope you find this demo and simple explanation on the use of tuple very useful and relevant. Python, just for sake of illustration again or revision, the tuple here does not have the flexibility of list, and it doesn't for the right reason. It's not meant to be updated. Its elements are not meant to be updated. They are not meant to be sorted or popped, as the case may be. Rather, they are meant to be static, and they have their generic use cases in programming environment. I hope you find this video very useful and relevant. If yes, click on like and subscribe to the channel and give me your feedback. I look forward to seeing you in the next video, which is going to deal with sets. Bye for now.